we have our inside domain and our outside domain restriction. So the inside here is the x must be greater than or equal to b. Okay, so it must be greater than or equal to b, and that represents our inside domain restriction. And then we also have this outside, which again, we're not going to be as concerned about that, but there is a restriction here, and this needs to be bigger than 0. So we need to say that x must be greater than or equal to a over 3. Okay? So those are our domain restrictions in terms of a and b. Okay, so that's when they ask for this, we need to make sure we understand that that we have these domain restrictions based on absolute value. And the main one is in between, okay? It's going to be in between these variables. So this is going to be the positive version. Okay, so remember we have our positive version and we have our negative version, which I forgot to list here. Our negative version of our domain restriction is when x is less than b. Okay. Our outside restriction just has to be greater than 0 though. So what are the values for x, our solutions to the equation? Okay, well, let's solve this. Okay, so we can just solve this and we'll do the domain analysis afterwards. We'll just go ahead and solve it. So we end up with 3x equals, absolute value 3x equals 3x. So we have our positive value solution, which is 3x equals 3x. Well, when is 3x equal to 3x? Well, that's when x can be anything. We get x equals x, or we get 0 equals 0. This really means all real numbers. Okay. What about the negative version? Okay, so here's our negative version. Well, the inside 3x must equal negative of 3x. Well, if this is the case, we get 6x equals 0. This one is a solution of x equals 0. Okay, so at x equals 0, we have a solution, a unique solution. Here we have all real numbers, but remember that there is a domain restriction here. So let's do some domain analysis here. The domain of the green is when the inside is bigger than 0, so that's when x is greater than or equal to 0. So putting these two parts together, the solution is going to be not all x's, but when x is greater than or equal to 0, that is our solution. So when x is 5, right? X is 5, yeah, that works. But when x is less than 0, we get -1, for example, gives us -3. The absolute value of -3 is not equal to -3. Okay, so it doesn't work outside the domain. We also have it equal to 0. However, we did include that here, so that represents the boundary. So essentially, we get a kinked graph. Okay? So when we look at the graph of this, then, the graph of this is going to look like this. So and I'm going to write the domain here. So when the domain of this is when x is less than 0, it will behave like a graph y equals 6x. Okay, so it's going to look like this. It's going to hit 0, so there's our solution, x equals 0. And from x equals greater than 0, we're going to have x equals x, or the graph is just going to be 0. So it's going to be equal to 0 all along that line, so that shows why it looks like this. If you go ahead and graph it, we're going to end up with a graph that looks like this. Okay? We can always test as well, but however, this is difficult to test because we can't test every single number. We have to understand that when we get this all real numbers, we end up with a situation where the graph is going to be along the x-axis, and we have to use the domain then to establish what values of all real x are going to be part of the solution. Let's look at this next one here. So we end up with negative 2x equals 3. This is going to end up being positive 2x. Okay. So again, we can work out our positive and negative versions here. So positive is going to be when negative 2x equals, well, 2x. Okay. Here we end up with 0 equals 4x, and x is equal to 0. Now technically this is could be our negative version, but if we put it with our domain, we can say that, well, if x is, since it's 2x, x is less than or equal to 0, this is going to be our domain. X is equal to 0. For the negative version, we end up with negative 2x equals negative 2x. Well, when is negative 2x equal to negative 2x? It's equal to, well, we can reduce it to 0 equals 0, which means x is all real numbers. But now we have to be able to interpret this x is all real numbers, we have to interpret the domain of this. This is going to be when x is greater than or equal to 0. In fact, we'll just say greater than 0. So we have a solution at x equals 0, and when x is greater than 0, we have all real numbers. So together, the solution is just going to be x is greater than 0, and because we have the equal to 0, together our solution is going to be greater than or equal to 0. So our graphs are going to then look like this. For less, if I were to sketch this, and again I encourage you to do this on Desmos. If I were to graph this function, okay, 2x, negative 2x minus absolute value of negative 2x minus 2x equals 0, you would end up with a graph that looks like this. So the green part of this graph is going to be a graph that equals 4x, and it's going to hit 0. Okay, and when it goes along that, when we have 0 equals 0, we end up, for all real numbers, we end up having a horizontal line along the x-axis, so that shows that that any x will be equal to 0, and that's what the solution of the graph looks like.